Welcome. In this report we review the 2010 University of Michigan Physics Olympiad. Upon arrival, the competing teams registered on the third floor of West Hall, which is located on Central Campus in downtown Ann Arbor. Students enjoyed a breakfast in a commons room adjacent to the registration desk.
Does anyone need to make repairs to their pasta bridge right now before the event?
The contestants then gathered in a seminar room for an introductory session in which organizational details were explained and the event coordinators were introduced.
Professor Vanessa Shi over there. So Vanessa, can you please hold up your sign so that everybody see here? Okay, so Vanessa will be waiting for you near the exit. Then we have the colorful drinks, and that's hosted by Professor Keith Rias.
I'm the guy with the rain hat.
Okay, so then the pasta bridge event is led by Professor Hui Deng, and it's organized by the Society of Women in Physics.
In the following, we show a few scenes from each of the events. We begin with the laser maze event, in which contestants align the laser beams through various optical components.
Yes, so you'll work on the test and the alignment simultaneously, and when you're done with both to your satisfaction, then you can come talk to us. Yes, we can call out 15 minutes.
And they all need one of these, right, to put the school name and
Right.
Yes. So your school name.
Here you can see a close-up of the optical setup.
Should we draw those now? Even though we don't do it till one.
No,
Just give you one when
teams
you're
were running this morning. Okay, so any other questions? So the mirrors have to stay within the yellow tape, and the aperture, this movable aperture has to stay within the green tape. And don't touch anything within the red tape. Other than that, choose the teams that are running this morning. You can choose your laser maze. There are 5 stations.
They are all as equivalent as we could make them.
Is everybody ready? Any other questions?
Okay. So if there aren't any more questions, you may begin your test and alignment now.
Next, we show several of the pasta bridges that students built at home and brought in. Here you can see a novel design. Some of the bridges were very light. Scoring was based on the ratio of the weight the bridges could carry and the bridges' own weights. Here you see a bridge being prepared for testing.
It doesn't really add much.
No, but it's still better to be precise.
Get it one top.
BLs and the treaties do the positive bridge right now. You know where that is? Okay.
The attached weight was gradually increased up to the breaking point.
We did. We did figure eight. We would have come.
To determine the score, the weight of the load was then measured and divided by the bridge's own weight.
80 pounds.
Whoa.
Now we got
After successful testing, all bridges eventually ended up here. We'll move on to the egg catcher event, where students built and brought in devices designed to catch bear eggs dropped from a window more than 10 meters up. Here we see two contestants take the theory quiz. The narrow window in the background here is the egg drop location. Here we pan from the egg's impact site up to the open window from which the eggs are dropped. The enormous wind on the competition day enhanced the challenge. In the following we will show several of the egg drops.
I got it!
Anytime, buddy. Not really. Hey! Woo!
For lunch we had sandwiches and liquid nitrogen ice cream.
Yeah, I mean, the question is, would the bullet explode from the bullet?
He kept going.
It would be really cool though. Well, right, it cracks and it shatters. Nah, it's a metal bomb. If it were a plastic bomb, oh, you mean what?
Here Mallory is preparing more of the liquid nitrogen ice cream.
We should have liquid nitrogen ice cream because of Obama. We should be like, right? Maybe like we make ice cream. We'd be like, what did you just say?
When does Frosty
This is better than my breakfast recipe because if you have to like thaw it out in the freezer and
I'm definitely gonna do that. I'm starting over it tonight.
No! Be sure to send me.
We move on to covering the solar car race. Due to the absence of sunlight, the event took place indoors, with a lamp replacing the sunlight. Last-minute engineering tweaks were allowed in the competition.
So, Mr. Mercer, want to have like less friction? The wheels touching the ground also creates friction. Right.
Okay, everybody ready? Ready, steady, go.
There's moves. Please.
Keep it going, keep it going.
Don't turn.
Okay, ready, steady, go.
Take it out. Keep it dead on there, man.
Several cars whisked across the racetrack in as little as 7 seconds.
I don't think we do. Wait, can they go back up here? Okay, two again. Ready, guys? Ready?
See if they have any table.
No, actually. Steady, go.
The ROG Ramble event was held in the atrium of the Math Department. The main objective of this competition was to make a rubber band-driven model airplane rise off the ground and stay airborne for as long as possible. Here we see a quite long successful flight.
Oh, that really hurt.
Still flying.
Okay.
It's a good thing you made it off the ledge.
This one is a dramatic nose tumbler. The catapult event was conducted outdoors on the Denison lawn. Due to adverse weather conditions, some spectators opted for watching the event from the inside out. Contestants brought in catapults built at home. They fired water balloons at a target ring. Scoring was based on distance and accuracy. In the following, we show several of the shots. Occasionally, the audience got showered, like in this particular shot. Starting at about 3 p.m., Professor Aaron Lienhardt presented the Physics Bowl, in which contestants were scored on physics questions about mechanics and electromagnetism problems.
8 grams, that doesn't matter too much. The question is the following. I'm going to ask one of you to insert your finger into this liquid, and then we'll be reading on the scale decrease, stay the same, or increase. And the point is, when you insert your finger, I don't want you touching the beaker at all. I don't want you putting your hand on the beaker. I don't want you putting your finger on the beaker. just putting your finger in the water. Does that make sense? Finger in the water, no touching the beaker. Does the reading on the scale go up, down, or stay the same? Sits here and he throws the ball up into the air. Only, of course, if I load Albert Einstein's spring. And the ball lands back in the cart. My question is the following: if I give the cart a good hard push so the cart goes flying along and then Albert throws the ball up into the air, is Albert actually going to catch the ball way over here? Or is the ball going to be ahead of Albert or behind Albert? Does the question make sense?
Yeah.
All right, so you and your friend...
The Olympiad was concluded by an awards ceremony. While the physics bowl was in progress, award certificates were prepared in the space between the two Denison lecture halls. Next we will show the presentation of several of the awards.
And first place, can I get a drum roll? Is Fabio Sanchez and Prashant from Troy Adams.
Second place, silver medals, joint second place to Justin Waraniak from Kickoff from Paris Catholic High School. Also, well done there.
Goes to Nico Ramu and
Olympiad team number 1 and Olympiad team number 2. And also Troy Adams High School Olympiad team number 5. Scoring 80% on that physics quiz, so we certainly earn you an A in any class that over time here. So congratulations.
This concludes our short movie. Check our website for the announcement of next year's Physics Olympiad, which will appear soon. Thanks all for coming and making the event a success. Spread the word about the University of Michigan Physics Olympiad. We hope to see you again next year. Have a great summer.